Hello again. Thanks for joining us. This is Space Nuts. My name is Andrew Dunkley, your host. So good to have your company. And a very exciting episode coming up. And if you're watching on YouTube, you'll notice there's an extra face, a much prettier face than mine, and certainly much superior to Fred's. Now, what we're talking about today is the DART mission, which happened, our time yesterday. And we have someone who was on the ground with NASA to experience it all and watch it all unfold. So that's why Marie-Claire Mercier is joining us on this episode. We're also going to Mars because China has been digging deep into the interior of the planet and made an amazing discovery. And we will have audience questions about the effects of an asteroid impact, strangely enough. And we are going to talk dark force theory, whatever that is. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And we welcome, as always, his good self, Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. How are you doing today?
I'm wet. Very, very wet.
Yeah,
I am
you're
so. I know everyone's in drought in North America and Europe, and I feel for them as we just came out of a big drought. Seems so long ago now, but it is so wet here. Got rained on again today, rained on yesterday, rained on last week. It's a mess. Everything's
look a bit damp,
soggy.
I have to say. You do look damp and a bit soggy around the edges.
Yeah.
Fortunately, it hasn't been wet here in Sydney because half our roof was missing for most of the day. Because
the storms.
Well, no, it wasn't. No, it was just routine maintenance on the roof. But we chose a bad week for it, or rather, the roofers chose a bad week for it. Anyway, we had a dry day today.
You chose a bad year, actually.
Yes, that's right.
Been raining. It's been raining for nearly 3 years, Fred. It's ridiculous.
So they tell me. Yes, that's right.
Also joining us is Marie-Claire Mercier. Marie-Claire, it is so nice to have you join us on this edition of Space Nuts. Thank you so much. I know it's 1:30, well, nearly 2 o'clock in the morning your time. So we really appreciate you putting the toothpicks in your eyes and staying awake for us. It's fabulous. Thank you so much. And welcome.
Thank you so much for extending it. So here's some of my insights from yesterday's historic event. So,
Yes, indeed. It was amazing. We might as well get stuck straight into it if you're ready, Fred, and talk to you about what happened yesterday. Fred, I suppose just paint the picture for us. What was this all about? And then we'll get Marie-Claire to explain what she saw.
Yeah, the DART mission spacecraft launched back in November last year with a half-ton spacecraft that essentially hit an asteroid by the name of Dimorphos, which is the moon of an asteroid called Didymos. And the idea is to see whether that impact will have changed the orbit of Dimorphos around Didymos, because that might be one day the kind of thing that we need to do to deflect an asteroid that could be threatening our planet. And I'm going to stop there because we have an expert in the room with us who was there when that impact took place, not in front of Dimorphos, waiting for it to happen, but certainly in the control room, which is very, very exciting.
Indeed, very exciting. Marie-Claire, just tell us how it all unfolded yesterday. How did you get to go in the first place? How did that happen?
So I think we were. I just wanted to actually show you guys my shirt.
Oh, look at the T-shirt.
From the Johns Hopkins Applied Physics Laboratory, so official part of the team. So how did it happen? Because I believe NASA, every time they do have a project or upcoming project, they try to extend the invite to social media influencers or science aficionados to apply to their slots. And it so happened it was last month. I remember it. I was browsing through my Instagram, and I was following, NASA account, Johns Hopkins APL, and there was a slot to apply and I applied, and they got back to me a week after, telling me I got accepted, and the rest was history. See, meeting everybody.
Indeed, it was.
Meeting everybody from
Yeah.
NASA,
How,
the lead mechanical engineers and the project managers for the whole DART mission was just very exhilarating and remarkable.
yeah,
Just
it was a big day too, wasn't it? I mean, you were there for 12 hours or something?
yes, basically we had a full day's agenda because what happened was we had to be there at 8 a.m. There's a lot of security check, very, very tight security. And not only we met the head of the Planetary Defense, Lindley Johnson, I met Dr. Kelly Fast, and a lot of different people, Dr. Thomas Zurbuchen, Dr. Bobby Braun from NPL, and David Corelli, Lisa Bowman, and they also allowed us to have a tour of the whole Johns Hopkins APL laboratories and different workrooms. And the funniest thing is that we were escorted by so many people because there are certain areas where you can take pictures, but most of the area is very restricted. Even when you're just walking in a hallway, regardless the hallway is just plain, but there may be a scientist carrying a classified record or talking to another scientist carrying another classified record
Yeah.
that record nor take pictures. So it was like how we see it on movies. It felt that way when it comes to security. And
Right. Now, tell us about the experience itself. I know you did a few tours and you got to see a lot of the facility, but when it came to the crunch and you were in the room with everybody else watching this historic moment unfold, what happened? I did see some of your social media posts, so I got a bit of an insight into what was going on. But from my perspective, I got to watch it on a small screen computer at my radio station, and that's as close as I got. But for you, it was all big screen stuff by the look of it.
It was. So basically, it's kind of like watching a real live Armageddon movie, unfolding right in front of me. And obviously there was a lot of, you can feel the tension and the pressure in the room because they have mentioned that at that specific moment, we don't know what Dimorphos would look like, whether it could be a donut-shaped asteroid or whether it just be a clumps of rocks floating in air. We don't see that until a couple of minutes before impact. So it was really like heart-wrenching to say until the final couple of minutes when the Draco camera was already showing at least that it's actually a denser, solid target that we kind of like.
It almost looks spherical to me. It almost had a uniform shape about it.
Yes. So they even actually mentioned that we could actually miss the target. So that was also in everybody's, thinking that it could be a hit or miss. So we were just praying till the last seconds and minutes before impact.
Now, what I'm interested to know is that from my perspective, watching on a little computer screen, I could see the main asteroid in the picture as DART was moving past it, and you could get a pretty good insight into what that particular asteroid looked like. But as we got to the moonlet, Dimorphos, it became more and more vivid. What was the picture definition like from your perspective? Because I was able to make out rocks and debris on the surface of the moonlet on a tiny little computer screen. How did it look to you?
Well, it's how it looked to you guys is how it looked to us, but it just happened to be in a bigger screen.
Yeah.
Yes, yes, because what happens is that DART is taking pictures in seconds before the impact, and obviously once those, I think they needed at least 3 or 4 pictures because it's a suicide mission basically.
Yeah.
That whole satellite is going to be gone. So I think now that they're looking at the pictures, and probably it's going to be coming out in NASA available once the pixels and grains and everything that they fix after editing the pictures. But as how you guys see it, that's the same thing that we saw, just in bigger screen, just with people screaming in the command center and everybody just like.
So describe those last moments as the spacecraft was about to hit. How did it feel where you were? How did the people respond? How did those that were in control until those last couple of minutes, how were they reacting to the whole situation?
Everybody, actually, the moment that we saw how Dimorphos looked, we were already like, okay, yes, come on, hit it. So it's basically kind of like...
It's not a donut. We're not going to go through the middle.
We're not going to go through the donut shape. So thank God. Okay, all right, 1 more minute, a couple more seconds, and here we go. And everybody just started screaming and shouting, and, like a moment of really relief that years worth of dedication has finally come to an end. But basically, they were able to hit the target.
Yeah, I heard that the miss margin was like 17 meters, so they were pretty close to hitting exactly where they aimed, which is fabulous.
Yes.
Of course, that's not the end of it, is it? It's the end of the spacecraft. It's done its job. It hit the target at 22,500 miles an hour, or whatever the speed was, or 14,000 miles an hour, 22,500 kilometers an hour. Now they have to analyze the data and see if it did exactly what they hoped it would do, which is knock the moonlet off its trajectory slightly.
Indeed. I believe the European Space Agency is also going to have a follow-up project to see the after effect of the impact. So
yeah. I have heard they're possibly going to send another craft out at some stage. That's the plan I heard.
It's called HERA. HERA. Yeah.
I knew you'd know, Fred.
Yes.
Yeah.
I've got a question for Marie-Claire, if I may, and sort of along those lines. So DART was accompanied during that suicide mission by a little CubeSat called LissiaCube, which is an Italian spacecraft, which was there to sort of film what happens. I think it followed the DART spacecraft by about 3 minutes. So the impact itself may well have been recorded by the LissiaCube. Do you have any inside information about when we might see the images from that?
That will be still classified until they put it out. We actually had a press conference afterwards with the whole team for DART, and they have mentioned that the LissiaCube that they have to look at the pictures first and then study the data of the recording before they put it out in public.
Yes.
So, yes.
Okay.
I did see something online today, which I don't know if it was a telescope or something, but they did show a sort of an image of the moonlet as it got struck, and there was some kind of plume that came off it as the impact happened. But I don't know if that's real. It looked fairly genuine to me.
Yeah, I think ground-based telescopes were actually observing, but this thing's 11 million kilometers away.
It seemed a bit odd to me, but
but anyway,
it might be real. Who knows?
What I heard was that the LissiaCube images might be released towards the end of this week. So that sort of ties in, Marie-Claire, with your insight there. about that. I
now
would assume they're being
had
processed by the Italians because it's an Italian spacecraft.
okay.
Yeah.
We've had a question come in from YouTube asking how long it'll be before we get the results. My understanding is days, possibly weeks. What's your understanding, Fred?
Oh, in terms of the orbit,
Yeah.
it's a question of, well, Dimorphos goes around Didymos once in 11 hours, roughly, if I remember right. It might be nearly 12 hours, actually, I think. And so that's quite a short orbital period. And there should be an immediate effect with this acceleration. The hope is that it will shorten the orbital period. I think that the hope is that it will actually knock several tens of minutes off the orbital period. But I think the mission's counted as a success if it knocks 10 minutes off the orbital period. So those results, they might take a while to come. But yes, I would guess certainly within weeks, we should have some really good insights into that. What about, do you know any more, Marie-Claire, on that?
On that, I that's what I heard too in a couple of weeks. That
Okay, good.
Yeah. I got some feedback on that image I saw of the impact plume, and we're being told it was in fact a ground-based telescope in South Africa that took those images. So it looks like they did actually get vision of the impact from a ground-based telescope, which is extraordinary. It's a pretty good. If it was a fake, it was great. Obviously, it's not. It really was filmed. So that's fabulous. Anything you'd like to add in conclusion, Marie-Claire?
All I can say is wow.
Now that's another thing. That's a signal that.
No, basically,
I'm kidding.
The DART mission is the first planetary defense with deflecting an asteroid using a kinetic impactor, because there are other different methods of deflecting other hazardous celestial bodies, but this is the first time that we're actually doing it in history.
Yep.
So we made it. Like we were able to also witness this. So this is something that is spectacular, and hopefully we don't have to experience that in real time to be doing that. But just the mere fact of being able to send out a test shoot like that is truly remarkable in science innovation in history.
It is quite so. And as NASA said, if we do nothing, something's going to whack into us one day. So yes, we do need to look at options when it comes to defending the planet. And the other options that have been talked about in the past are gravity tractors, which would need decades to be effective. So we wouldn't have that much notice, I wouldn't think, in some circumstances, and they might not work well on very big objects. The other option is nukes. And I think, Fred, you and I have talked about the nuclear option before, and it has its own limitations. It would be a last resort rather than a first option, because if you hit a rock and blow it to smithereens, that's fine, but then you might be showered in dozens and dozens of rocks, which is an even worse situation to face. So the deflection option sounds like it's probably the best bet going forward, and we wait with bated breath as to whether or not they've succeeded.
Sorry, go on, Marie-Claire. Go ahead.
So sorry. If you actually, I just wanted to mention that there is this. We had the opportunity to see a private viewing of this documentary called Asteroid Hunters. So I'm not sure if you guys have heard of it. It was written and directed by Phil Groves, who was also with us during the viewing. And it is, as what NASA said, and even the Planetary Defense have said, that is the most accurate information that one can get when it comes to anything deflecting asteroids, as opposed to the movie that we see. So,
yes. Yeah. I like the idea of the kinetic impactor a lot better than the option that you didn't mention, Andrew, for
What's that?
changing the orbit of an asteroid, painting half of it white. Because
Oh, yes.
painting it white, if you can do that, actually puts an imbalance in the thermal properties of the object, and you get radiative effects. You've got to have years and years warning though, in order for something like that to make any difference at all. But yeah, a good clout is, I think, the most direct way. I loved, forgive me, Marie-Claire, but and you will have seen this, as a scientist who's many times looked at the readout of images from astronomical instruments, where basically the image reads out from one side to another. We do it all the time in astronomical spectroscopy. But I loved that final image from DART, where the readout started but then stopped, and so we just got the top, the top segment of the image showing the surface of Dimorphos, and then nothing, which told you unequivocally that the thing had done its job and been blown to pieces by the impact.
Yep.
Exactly.
Yep. Absolutely.
Afterwards.
Yes, I saw the red. Yeah.
Yeah, me
Which
too.
we-
Yeah.
Yeah.
I think people should be able to watch the video if they haven't already seen it on various online platforms and on the news. But they should be able to go to the NASA website and look it up and watch the video of it, because it's worth watching. I didn't realize I'd get so excited watching it, but I got caught up in the moment as it got closer and closer. My eyes just went wider and wider, and finally, boom, gone. LOS, I think is what they said.
You were watching history being made, Andrew. As
Yes,
Marie-Claire
yes,
said.
indeed.
It's a historic moment. Yeah.
Indeed. Marie-Claire, thank you so much for staying up in the middle of the night after flying back to your home after such an amazing day at NASA to watch the DART mission. We so appreciate it, and we were glad we could link up with you and have a talk about it. Thank you so much. Look, you're welcome to stay and watch the rest of the show, or you can tuck yourself off into bed. It's up to you.
Yes.
You go to bed.
Andrew and Fred, and I can't wait to listen to this session for the next one. So again, thank you so much. It's
Very good.
Speaking to you, Andrew and Fred. Thank you so much. Have a good one.
No, it's been a pleasure, and I just want to say thank you so much for making yourself available in the wee small hours, and stay safe. Thanks so much.
Yeah.
Likewise.
Keep up the good work, Marie-Claire. Keep up the good work.
Thank you so much. Thank you so much. I appreciate it. And I appreciate you guys just, doing what you guys love and sharing everything to us. It's something that I look forward to listening every week.
Thank you. We appreciate it. And we'll talk again soon. Sleep
Definitely.
tight.
Thank you so much. Have a good one. Bye-bye.
Okay.
Bye.
Bye, Marie-Claire. Thank you. And this is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Space Nuts.
Now, Fred, let's move on to our next topic, which is Mars-related, and this involves a Chinese rover that's made a fascinating discovery, and it adds more weight to what we were probably thinking about Mars as, we'll call them salad days, when it had liquid water, when it had properties similar to Earth, until all of that was blown away by its unfortunate weak gravity situation.
Yeah, it's really interesting, and some of the details of this have surprised me, I have to say, Andrew. So this is results from the Jurong Rover that we know has been working on Mars pretty well since the Perseverance landed it. They both caught the same window to get from Earth to Mars back in July 2020, was it? They were launched, I think that's right. And Perseverance landed in February 2021. Jurong, if I remember rightly, I think stayed in orbit for quite a while before the rover was deployed down on the surface. And it's been very successful. It's working well. It's a smaller rover than Perseverance. It uses solar panels for its power source. And we've seen some lovely images from it, actually, some really quite remarkable stuff, including, wasn't it? Oh no, that was Chang'e, the one that had a tent on the horizon, or a shed or something that was on the moon. One of these images that looks like something else. The good old pareidolia coming into play to make us think we're seeing something that we're not. Anyway, that's not part of the story. What makes Jurong interesting is that it has a quite sophisticated ground-penetrating radar system, which works at two frequencies. Excuse me, high-frequency radio waves that actually give you really detailed images down to about 10 meters under the ground. But then if you want to look further, you go with low frequency, and because it's lower frequency, you get not as good detail, you don't get the same resolution, but that will take you down to 100 meters, which is really quite extraordinary. Getting penetration of radar to 100 meters below the surface.
I know, that is amazing.
Yeah, very significant. So what the scientists have done is identified different layers within the ground beneath the Jurong Rover. And there's two layers which have sparked their interest. One which is somewhere between 10 and 30 meters below the surface, and another one which is somewhere between 30 and 80 meters. So two distinct layers. These numbers are a bit vague, probably because those layers are actually, they vary in depth, and Jurong's got the capability of driving across the surface and actually probing ground penetrating radar at, in different places. So those layers, though, the upper layer is relatively thin, the older layer is relatively thick, and both of them have probably reflections that speak of large boulders, which are sort of down at the at the base of whatever layer we're looking at, with smaller boulders settling on top. And this is being interpreted as the possible result of flooding that was actually really quick. What one news outlet has described as catastrophic flooding. So something that took place really quickly. And what they do is they identify these two layers with two flooding episodes, which the lower one was probably in the region of 3 billion years ago, maybe a little bit earlier than that, in fact. Something like, the time that we think Mars was a warm and wet world. That's looking back to the era when we think those ocean sediments were laid down in the northern hemisphere of Mars, and probably when the flooding was taking place at Jezero Crater, which is where Perseverance is. And I should mention that the Jurong Rover is actually in a region called Utopia Planitia, which is basically a huge plain area, not that far actually from Jezero Crater where Perseverance is, but certainly too far for them to meet up and shake hands or whatever they do when you're a rover. So that 3 billion year old sediment is kind of what you'd expect. But then the upper sediment is suggested to have been created by a flood only 1.6 billion years ago. And that is much more recent, of course, in Mars's past. And it's outside the region when we think liquid water existed. And so something's happened at that time. We know there were glaciers on Mars at that time, and maybe, there was some sort of, some sort of climatic anomaly. Maybe they had an El Nino event on Mars, which is caused by water, but doesn't happen on Mars, but you know what I mean. You've got a warmer period than usual, and so perhaps some glacial melting, which gave you this flood and deposited these boulders in the region underneath Jurong only 1.6 billion years ago. So that's really interesting interpretation. Now, this all comes with a caveat because with the equipment that the Chinese rover has got, you can't separate or you can't distinguish between sedimentary material, which is stuff deposited by water, or lava, which is not stuff deposited by water. And
No.
in fact, we've recently seen some results, which I think came from Perseverance's radar detection, because Perseverance also has subsurface radar, which showed that maybe Jezero crater itself has a layer of lava underneath it, underlying it. There's quite a lot of really interesting stuff coming out about this at the moment, not with this inability to distinguish between sedimentary rock and basaltic rock, lava, or igneous rock. So that the jury's still out on that, but the likelihood, though, seems to be that these boulders might very well have been formed by a flood of some kind, the ones that have been detected by the Chinese rover. We wait to see whether any more information might come out about that. And it is even possible that there is ice underneath there as well. The authors of the work say that they can't actually eliminate that possibility, that there might be salty ice underneath the surface.
Quite incredible. And look, it stands to reason that lava is a plausible explanation, because a new theory about the death of the dinosaurs has surfaced in the last week or so, suggesting that, yes, the asteroid impact or impacts, as we recently discussed, certainly were major contributing factors, but they also have found that there was a lot of volcanic activity around that time too, which might have finished them off. And they've suggested there was at least one lava flow that covered an area as big as continental Australia, which, imagine the effect of that.
Yes. That's right. That's I have seen some of that. Not recently. I have seen work that suggests that it was partly volcanic as well, and there's the possibility that it was an impact that actually shook up the volcanism.
Very likely.
So that you've got, if you get clout by a 15-kilometer diameter asteroid, could do all kinds of things to the tectonic activity in the region.
At the very least, put an extra hole in your head. So
yeah. If you're a dinosaur, that's right.
Yes, indeed. But it's a fascinating discovery, and hasn't China been amazing with everything that they're doing? And from what I've been reading recently, they've got bold plans. They're looking to get to Mars. They're looking to put a rover on Mars. They're going to take the UAE with them. Everybody's sort of got their eyes focused on China because they're really doing some extraordinary things, as is NASA, though, as we just discussed. But China's certainly galloping along in leaps and bounds when it comes to what have I heard people call it? Space Race 2.0.
Well, it's good, and Space Race to Mars is a good thing because it'll tell us more about Mars.
Yes, it will. Yes, it will indeed. All right. I hope there's more to tell about what the Chinese rover has discovered beneath the surface. I'm just so amazed by the technology that can get down so deep on a rocky planet like that.
Yeah, that's right. It's pretty good going.
It is. You're listening to and perhaps watching Space Nuts with Andrew Dunkley and Professor Fred Watson.
You're listening to Space Nuts, the podcast about astronomy and space science with Andrew Dunkley and Professor Fred Watson.
Pretty sure I just said that. Yeah, I don't know. Yeah.
Where did that come from?
That's a new person.
New little sting there. Whoa.
Yes. I've been playing with my equipment.
I can tell.
Let me rephrase. I've been playing with the new digital equipment. Dear, oh dear. Let's do some questions. I'm going to hand it over to Bob from North Carolina. He's got a ripper for us, which works well with what we've been discussing on this episode in regard to the DART mission.
Good morning. This is Bob from Asheville, North Carolina, in the United States. In a prior message, I think I heard Dr. Watson say that an asteroid impact would actually be more devastating if it landed over water than over land. And this seems pretty perplexing because you can just imagine there'd be a lot more damage done if it hit land. So the question is, what actually happens when these asteroids hit the kind of damage they cause? And I also wonder, what if it hit in some unique places, maybe Greenland, the Arctic, or even the Antarctic, and it didn't just collide, but it actually either melted all the ice or dislodged it, so there were massive repercussions after the initial impact had occurred. Thank you. I love the show and look forward to hearing your answer.
Thank you, Bob. Lovely to hear from you, and a great question. And water or land, which would be worse? I think you have talked about this before.
Yeah, I think that the answer, as always with these things, is it depends.
Yeah.
And one of the things it depends on is the mass of the asteroid, how big it is. Whether we're talking about something that is a dinosaur killer. In which case it doesn't really matter where it lands, or something a bit smaller than that. And I've seen recently simulations. Now, I think they were in connection, Andrew, with that. Remember we talked a couple of weeks ago about an asteroid, or it might be a couple of months ago, an asteroid impact off the coast of Africa, which has been kind of linked with the Chicxulub impact, the dinosaur killer. And that certainly landed in what was then an ocean. I think it was relatively shallow ocean. But the simulations showed the impact. And the first thing that happens is this sort of hollow cylinder of water is raised to an enormous height with the sort of centered on where the asteroid hit. And that basically kicks off a tsunami, which probably would go all the way around the world at least once, as I think that the idea with the Chicxulub event was that it did that too, because that hit in a shallow sea as well, what's now the Gulf of Mexico. So that's one effect. But when you've got something as massive as that, the water as massive as the dinosaur killer, the 15-kilometer one, the water really is almost an aside. It probably puts a lot of steam into the atmosphere because of the heat of the impact. But when you look at the simulation of an impact like that, you can see that the rock itself behaves almost like a liquid. It gets pummeled by this thing. There's a huge crater formed, and then it bounces back. And this all takes place within a matter of minutes. And you get a mountain range higher than the Himalayas, which then collapses just because the energy is involved. So I think at the end of the day, with a big impact, it's not going to make much difference. But with a smaller one, it might do. And maybe the tsunami would be more devastating than the local sort of explosive damage that you would get.
Didn't we discuss some time back that there had been a study done that suggested it wasn't so much the size of the object hitting us, but what part of the Earth it hit, depending on what was in the crust?
That's another aspect of it as well. Yes, I mean, in the end, size is everything, but there are. It's a nuanced thing, depending exactly as you say on what sort of materials are there. And I can't remember, there was something, wasn't it, potassium-rich rock, I think that story was connected with, that said that something like that would do more damage than milder forms of rock. I can't remember the details, but yes, I think you're right. That's certainly true.
Just as a little aside, I suppose it is somewhat related. You talked about the way water would plume if an asteroid hit an ocean or a sea. The Tonga volcano, I read the other day, blasted 50 million tons of water into the atmosphere, which they think is going to affect our climate for a few years, possibly make us a bit warmer.
Yeah. that was
Fascinating.
it's certainly that explosion was, it was comparable with a reasonable sized asteroid coming in, so maybe 50, 60 meters or something like that.
So, I mean, technically speaking, we got to experience the effect without the total destruction of the planet. Although it was pretty devastating for the locals, which they're still coming to grips with. Yeah. Thank you, Bob. Lovely to hear from you, and a terrific question given what we've been seeing from NASA this week. And now, look, I hope I got your name right. I'm not sure. It's I think it's Boz in The Hague. And this is a fascinating question that we're going to have a bit of a talk about.
Hey guys, this is Bas from The Hague in the Netherlands. I love the show. Couple of questions. I've been reading the Three Body Problem trilogy by Cixin Liu. And in recent episodes, you guys were talking about the Drake equation and Dyson spheres and the James Webb Space Telescope, making all these exciting discoveries on exoplanets. But I've been curious. First of all, do you guys know about the dark forest theory, his second book, but also the theory that comes along with it? And if you do, I'm really curious what your guys' opinion is about that theory. And third, final question is, with the James Webb Space Telescope making all these fascinating, beautiful discoveries, should we actually be looking for extraterrestrial life, or is that something that might even be a danger to our civilization and humanity and stuff like that? Once again, love the show. Would like to hear from you guys. Keep up the good work. See ya.
Thank you. I hope it's Boz, but thank you anyway. Lovely to hear from you. Hope all is well in The Hague. One place I didn't get to visit while I was in the Netherlands about 4 years ago, but maybe I'll get back there one day. Fred,
lovely spot.
I believe so, yeah. I mean, we only ever hear about it in the news from time to time for all the wrong reasons.
Well, there's a really good reason why we should talk about The Hague, and that is that it was in The Hague on, I think, the 23rd of September, 1608, that the telescope first appeared in the historical record.
There you
and Marnie and I went there on the 400th birthday and celebrated with a cake that was made for us by the cake makers to the Dutch royal family that had a chocolate telescope on top. We had a party with all our tour guests there back in 2008 to celebrate the 400th birthday of the telescope. Yeah, it's a great spot. Some fantastic history there. Great scenery. Schweningen is the name of the seaside town that's associated with it. So great spot. Should go next time, Andrew.
I should indeed, yes. I'd love to. Now, Boz asked about the three-body problem. Now, I've just done a bit of a quick look, and it was by a Chinese writer, Liu Shijin. It's the first volume of a series. Now, I understand it's science fiction, but I've never heard of it and I haven't read it. So obviously I'm not in a position to comment on it. But I think it brings into being dark force theory.
Yeah, I think one of our, I think we've had a listener question before on the three-body problem.
Right.
Or maybe it was on a broadcast that I was doing with a listener question. I can't remember, but it certainly crossed my path before. So I don't know what the dark force is that's in that book that the author has identified. But there is a constant speculation in the world of physics that the four fundamental forces of nature that we recognize, the strong and weak nuclear forces, the electromagnetic force and gravity, that those forces are not all that there is, and that there is a fifth force, which is sometimes called quintessence, which has been identified by some as maybe what causes the dark energy that we see in the universe. And that's perhaps where the link comes from, the dark bit. So quintessence at the moment, it comes and goes, it pops up every now and again in physics papers and then disappears for a while. It's one of these things that's a bit unfashionable, or fashionable and unfashionable. But then it may well be that we finally do secure some observations that might reveal that there is a fifth force. And there is work that's gone on quite recently, and it's about the decay of the W boson, which is one of the forces that carries the weak nuclear force. That it behaves in a peculiar way that some have said is an indication of new physics and perhaps will lead us to the fifth force, the dark force. So there's work going on with that, and I probably should be more across it than I am. But it does come and go. As I said, it's a bit like fashion. It's suddenly we're all talking about quintessence, and suddenly we're not anymore. But it has been linked as a perhaps a source or reason for the dark energy that we believe is what's causing the universe to expand ever more rapidly. So those two, I think, are linked together.
Yeah.
So
now, the third was there more, or do you want to go to the third part?
No, I was going to go. Yeah, move on to the next.
Right.
One.
Yeah. Should we look for ET?
Well, yes, we should. As long as we, because looking doesn't actually make us dangerous. It doesn't bring us. It doesn't put us at any higher risk than we are already from ET finding us, because we as a species have advertised our presence for a long time, not just by radio waves, which are emanating in a sphere in space, which is now something like probably 140 light years in diameter, if you count the first high-powered radio signals in the 1930s as being when we became radio bright in the universe, and space science. It's telescopes, it's things like the James Webb Space Telescope. It's not sending things out there, although there are probes out there. Of course, the 5 spacecraft that are leaving the solar system, they're also markers of humankind. So we've already done it. We've already advertised our presence. So what we're doing now in terms of looking is not necessarily dangerous.
You've given me an opportunity to play with a new toy.
Oh,
you ready for this?
Yeah.
Because I'm going to quote Pink Floyd.
Is there anybody out there?
You like that?
That's very good. Yes, you were perfectly in sync there.
Very creepy.
The answer might well be no, but that shouldn't stop us from looking.
Well, yeah, and we are looking. We're looking for the same things that we produce: light, radio, which is a form of light. We're also looking for spectrum signs in their atmosphere for things that they have made that aren't natural. What else are we looking for?
The point I was going to make was the reason why. Yes, spaceships are a good one. The reason why we're not why we shouldn't stop looking is because we use the same technology to make discoveries about the universe as we do to try and find extraterrestrial life. So, it's all part of building up our store of knowledge. Spaceships is an interesting one because, maybe one day a piece of space junk that would turn up that might not be able to be explained by human sources. A bit like that thing that crashed into the backside of the moon.
Didn't that happen to a farmer in southern New South Wales recently? It turned out to be SpaceX or something.
I was going to say, it said SpaceX on it. But the one that crashed into the backside of the moon that nobody has owned up to, that's an interesting one.
That is.
Yeah.
I have my suspect.
Yes,
yeah.
I know you do. I'm sure you do.
All right, Boz, thank you. Great set of questions, made for some interesting discussion. But yes, I think looking for ET is a good idea until we find them and they don't like us. Then we'll throw rocks at them.
Yeah, it won't be by looking for them that they'll find out about us. That's the point.
Exactly. Good point. All right. Just about time to call it quits. It's been a long but very interesting show with Marie-Claire Mercier joining us after her trip to NASA to watch up close and personal the DART mission yesterday, our time. But if you do have questions for us, jump onto our website, spacenutspodcast.com or spacenuts.io. Click on the AMA link and you can send us a text question, or you can send us an audio question, or there's a tab on the right-hand side to send audio only. And all you need is a device with a microphone like this one. See? Yes.
Yeah,
and I'm replacing that, by the way. I'm getting a new one. It's going to be much bigger and in my face type of scenario. Yes, so please send us your questions, and don't forget while you're there to catch up on the back catalogue, our past episodes. Please leave your reviews on your favourite podcast distributor, because the more reviews, the more we get noticed, and the more people who join us, and the more fun we have. You can also visit the Space Nuts shop, where you can find all sorts of goodies. Oh, I forgot to tell Murray Claire, but she'll pick it up in the recording. We're sending her some presents for joining us today, so she'll get a couple of little surprises in the mail. And
well, won't be surprised now, because you've told
garbage. I forgot to do it. Well, he'll remember now. Fred, thank you as always. It's been a great pleasure.
It's always a pleasure, Andrew, and thank you for your patience as well.
Oh, no, it's a joy. There's no impatience required at my end, that's for sure. Thanks, Fred. We'll see you next week.
Sounds good.
Fred Watson, astronomer at large, joining us on this edition of Space Nuts, and thanks for your company. We'll look forward to your company on the very next episode. From me, Andrew Dunkley, bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.